Hey there, this is Jamie. Welcome back to Chapter 6 of Research Methods, where we're looking at hypothesis tests of the population mean. I'm going to walk you through using one of the questions from the end of our chapter in the Cam and Cochrane textbook. And that's question 636. If you're following along and you're in my class, you can open the data file called used cars. If you're not in my class, that is, you're just going to have to follow along, and I think it'll still be useful. So here's the question we're working with. According to the National Automobile Dealer Association, the mean price for used cars is $10,192. A manager of a Kansas City used car dealership reviewed a sample of 50 recent used car sales at their dealership in an attempt to determine whether the population mean price for used cars at this particular dealership differed from the national mean. So the prices for the sample of 50 cars are shown below. So we've got to do three things. We've got to first formulate the hypotheses that can be used to determine whether a difference exists in the mean price for used cars at this dealership versus the national average. Then we have to calculate the p-value, and then we'll use an alpha level of 0.05 to draw a conclusion here. So let's start at the beginning with A. Formulate the hypotheses that can be used to determine whether a difference exists in the mean price for used cars at this dealership. So we're asking ourselves whether the population mean price for used cars at this particular dealership differs from the national mean. So we're having a question about difference, right? We're not asking if it's greater than the national mean. We're not asking if it's less than the national mean. We want to know if it differs from the national mean. So this means that we're going to be using a two-tailed test. And if you want to enter a text box and use these Greek symbols, you can find it by going to Insert and then Insert an equation. And you'll see all of these different pieces. If you want to do that, you can put these in here. But it takes a little while, so I'm just going to show you as though it's done. So we've got a null hypothesis, which is that our sample mean is equal to the mean, the national mean, the null mean, the national mean of $10,192. So if I were to write this in, I'd say my null hypothesis is that our cars are the same price on average as the national average. So our average is going to be $10,192. The alternative hypothesis here is that they're not the same, right? That our average price is different than the national average and that difference is statistically significant. So I can say that my alternative hypothesis is that mu is actually not $1,192. So that gets us through part A. But part B says, what's the p-value? So here I've got us set up in a way that I like to use, and it's the same way that the same method that the book uses, is it outlines the pieces of information that you're going to need in the order that you're going to need them. So I'm going to start at the top with my sample size. We use the letter N to represent this sample size. And if I want to know what my sample size is, I'm going to count all the observations of data that I have. So each of these data points is the price of a single used car that this Kansas dealership sold. So how many did it sell? That's the sample size. That's the number N. And we can use that, we can find that by using Excel's count function. Equals count. I'll close my parentheses and press enter, and I can see that I'm working with a sample size of 50 car observations. So my sample mean is just equal to the average of those 50 observations. So here we can see that our dealership had an average vehicle price of $9,750, which is less than the national average of $10,192. We can also calculate the sample standard deviation by STDEV dot S So our standard deviation is 1,400. So what is our hypothesized value? The hypothesis value is the value that our average would be if the null hypothesis were true. So we're asking ourselves if it's different than 10,192. That's the value that we're comparing it to. So we're going to use that as our hypothesized value. And then our standard error, we're going to calculate using the formula. And the standard error is equal to the sample standard deviation divided by the square root of the sample size. So our standard error is 197.99. Then to get our test statistic, our t-value, we simply take the value that we're observing in our data, subtract the hypothesized value or the national average. I'm going to place both of that part of the expression in parentheses, and then I'm going to divide by the standard error. So my t-stat is negative 2.2324. And then to figure out what my p-value is, I need to know what my degrees of freedom are. So my degrees of freedom are the number of independent observation values that I have, which is one less than my sample size. So I've got 49 degrees of freedom. So what are our p-values? We're going to calculate all three, and we're going to talk about which one we need. So if we're asking if our mean price is lower than our hypothesized value, then we would use a one-tail test. But we need to start off by calculating that first. So we're going to do equals, and then we want the t-distribution function. And x is our test statistic t, and the degrees of freedom are our calculated degrees of freedom here. And then we want a cumulative distribution function. I'm going to close my parentheses, and I'm going to get 0.01509. So that means that 1.5% of all observations, I'm going to plop that in percentage for just a second, 1.5% of all observations in that t-distribution would fall below 2.23 t-stat values away from the mean. The upper tail value is simply going to be everything else. What percentage of values are going to be everywhere else? Well, we've got a two-tailed test here because we're testing based on inequality. And so our two-tailed test is going to be equal to double whatever is in whichever one of these corresponds to a tail. So the formula that we have is 2 times the minimum, because one of these is the tail and one of them is the rest of the distribution. We just want double what's in the tail. So we have 0.03019. This two-tailed p-value is the p-value that we're looking for this question. So our p-value is 0.030. That answers question part B. But the next thing we want to know is, so if alpha is 0.05, what's our conclusion? What can we conclude about this data? Are the cars at our dealership priced the same as the national average, or are they priced differently than the national average? So we can say with a p-value of 0.03, which is less than 0.05, right? We compare it to our alpha. We can conclude that the used cars at our dealership are priced differently than the national average. period. So there we go. That is a two-tailed hypothesis test where we're looking at the population mean. If we were doing a one-tailed test and it was in the lower tail, that 0.015 would be our p-value. If we were doing a a one-tailed test, and we were looking for the upper tail, if our test statistic was positive, then our p-value would be the upper tail p-value. But because we're doing a two-tailed test, we use the bottom p-value for the two-tailed test. All right, let me know if you have any questions.